In this Chapter 5 video, we're going to continue on with some ideas of probability. This time we're going to look at the probabilities of multiple events. The first event happening, then the second event happening, and then maybe even a third event happening. So multiple events in a row. And when you're examining multiple sequential events, you want to multiply the probability of each event. Or means add, but when you're looking at multiple possibilities, you want to multiply the probability of events. So for the probability of A and then B happening, you look at first the probability of A, then times the probability of B given A has occurred if they're dependent, if A is affecting B. And if they're independent, if they're not having an effect, then the probability of A and then B is just the probability of A times the probability of B, because A did not affect, it did not change the probability of B. So for example, let's look once again at a standard deck of 52 playing cards. We want to know what is the probability of drawing a king and then a queen if the cards are replaced after they're drawn. So I want the probability of a king and then a queen. So the probability of a king would be 4 out of 52 times, for the second event, for the queen, since I put that king back in the deck, there are still 52 cards in the deck, and there are still 4 queens. So the probability of the king is 4 out of 52, probably the queen is 4 out of 52. I can multiply those as they are. Say 4 out of 52 times 4 out of 52, and I get my probability is 0.0059 if I round that to 4 places. Similar idea in example 2. We want to draw a king and then a queen, but the cards are not replaced after they are drawn. So the probability of a king and then a queen, starting over, we've got a freshly shuffled deck of cards. The king is a 4 out of 52 probability. But if you take that king out, if it's not replaced for your queen, there are only 51 cards left in the deck. 4 of them are queens. So I could say 4 out of 52 for the king times 4 out of 51 for the queen, and that would be 0.0060 if you take it to 4 places. Example 1, we have independent events. King did not affect the queen, whereas in example 2, we have dependent events. The king, because it wasn't replaced, changed the probability of a queen from 4 out of 52 to 4 out of 51. This applies to not just 2 events, but 3 events or 4 events or even farther out. So example 3, again, it's a standard deck of 52 playing cards. They've been shuffled. We want to know what is the probability of drawing 3 4s in a row if the cards are not replaced. So the probability of a 4, a 4, and then a 4. Probability of the first 4, 4 out of 52. There are 4 4s in the deck out of 52 total. Now they're not replaced, so you've taken that first 4 out of the deck. You're down to 3 4s out of 51 cards. And for that third 4, you've taken this one out of the deck. You've taken a second 4 out of the deck, so you're down to 2 out of 50. And we're going to get a different result on the calculator when we do this. And it's something that'll be helpful not only in this chapter, but future chapters as well. So if I multiply these together, 4 out of 52 times 3 out of 51 times 2 out of 50, I get 1.809. Now, as a percentage, that would be 180%. That doesn't make any sense. There's not a 180% chance that you can get 4 4s in a row. Probabilities between 0 and 1. Note that you've got this e to the negative 4 on the end here. This is like scientific notation. This is saying you've got 1.8 times 10 to the negative 4. You need to move this decimal 4 places to the left. You're going to end up getting 0.00018. It's a very small chance that you could get 3 4s in a row from a deck of cards. Example 4 is almost identical. We want to get 3 4s in a row, except this time the cards are replaced. Probability of a 4, 4, and a 4 this time would be 4 out of 52 times 4 out of 52 times 4 out of 52. You're always putting that 4 back. There are always 52 cards in the deck. There are always 4 4s. So you could say 4 out of 52 times 4 out of 52 times 4 out of 52. You could use this caret key. You could make this exponential in your calculator. You could say, well, this is 4 out of 52 raised to the 3rd power. And again, it's not 455%. It's 4.55 times 10 to the negative 4. This e is 10 to this power, to the negative 4. So this would be 0.000455. You have to move this decimal 4 places to the left. 1, 2, 3, 4. Fill in the blanks with zeros. When the cards are replaced, we have independent events. When they're not replaced, we have dependent events.